So we have seen static data members and methods. Okay. Uh, and we were discussing about the access specifiers. Okay. So there are three access specifiers in C++, which is private, public, and protected. Okay. So why we need an access specifier means, right, before getting into that, let us see like how the visibility changes. So whenever a data member is declared private, then not only data member, it applies to method and constructor as well. Okay. So that can be accessed only within the class. Okay. And when you declare a data member as public or data member or any other member, okay, then that can be accessed anywhere. That means within the class, outside the class, in some other namespace, etc. Okay, we haven't yet discussed namespaces. Okay, next, protected. So when a member is declared as protected, they are accessible from outside the class, but only in the class derived from it. That means it is those are accessible definitely within the class and within the derived classes. Okay, right. So I think we have been already seeing this private public we got couple of errors. Okay. And the default access specifier in C++ is private. If you do not specify any access specifier, it's considered as private. Okay. Say for example, I make this constructor, okay, private. Okay. And let us keep this public. Okay. Fine. And obviously we are calling the constructor from here. Okay, right, in the main method. So now let us see how the program execution goes. Okay, so can you see here is in the private context and hence cannot be accessed. Okay, right. So whenever we create a class, okay, so we need to identify which members need to be private, which members need to be public, and which need to be protected. Protected we'll discuss bit later in inheritance. Okay, right. So let me just right get back to the previous slide. Okay, right. So why do we need access specifiers? Means it reduces the complexity of software. Okay, say for example, in a team there are a number of developers. Each developer may develop some classes and they may use some other classes. That means they may create object of that and invoke their methods, etc. Okay. So when you are a developer of a class, you need to be worried about the private, public, protected, everything. But when you are using some other class, okay, you need not worry about the private members of that. So what is the advantage? Thereby, okay, it will be less complex. You need to understand what you have access. Okay, thereby you can get your job done faster, okay, and better. Okay, all right. So the main advantage of access specifiers is it reduces the complexity, okay, of software, okay, and hence it improves the productivity, uh, okay, of the entire project. Fine. Okay. Okay. So let us move on to the next topic, okay, which is destructor. We had seen a class can have data members, methods, constructor. There can be one more thing, which is destructor. Okay, so what is a destructor? Okay, see, we are sure or we know that the purpose of constructor, it is used to it is used to initialize an object. Okay, that means it is used to give proper values to the data members so that the object is create okay fully created and properly initialized, and hence and further some other methods can be invoked. Okay, uh, right, of that object. Fine. Now, okay, so what is a destructor means? A destructor is also a special member function that gets invoked implicitly, okay, whenever the object is deallocated. That means it is destroyed and deallocated. Okay, so what is how a destructor looks means a destructor looks like this. It has the same name, okay, fine, as the class, but it is prefixed with tilde operator, and whatever the statements are there, you can have it within these global braces. Okay, right. And obviously, the destructor does not return anything, and destructor cannot take any parameters. Okay, right. So, whenever you are deallocating an object, whenever the object is destroyed, maybe you want to perform some activities, maybe you want to deallocate memory. Okay, this is required only when you have pointers as data members. Okay, all right. Or maybe let us assume you have a class, maybe in the constructor you are connecting to a database and you are performing all the operations, and in the destructor, whenever that object is getting destroyed, okay, the database connection may no more be required. So it can be disconnected, database connection. Okay. So right. So that is the purpose of destructor. Okay. So let us see an example with the destructor. Okay. Right. So here we have an example. So let us take it. Okay. So here we have a class and the name of the class is base class. Okay. So there is no derived class here. Okay. So we are not yet, we have not yet discussed inheritance. Okay. Okay. Now let us see when the destructor gets invoked. Okay. Of course, you can have the data members. You can have other member methods. Okay. Right. Okay. So here the call goes to the constructor. Okay. And the destructor gets invoked automatically, okay, when you go out of the scope of this. Okay, right. So now let us see if the destructor gets invoked or not. So as you can see here, okay, the execution starts here, and here the call goes to the constructor, and whenever you are going out of the scope at this point of time, the destructor is automatically invoked. Okay, right. So maybe you may think, do we need destructor for each and every class? Okay. In case you do not want to deallocate anything or perform any other activity, But destroying the object in case you do not have that requirement, okay, you don't need the destructor. Okay, right. So whenever there are pointer data members, so that time if you want to deallocate the memory of those, okay, right, then it may be required. Okay, all right, fine. So that's about destructor. Next, let us talk about overloading. Okay, so what is overloading? What is method overloading or function overloading means? Okay, a function can have same name but with different number or type of parameters. That is called method overloading. Okay, right. And the other name for this method overloading or function overloading is compile time polymorphism. Okay, right, right. We'll talk about polymorphism more in inheritance. Okay, right. So as you can see in this example, let me try to zoom it. Okay, so as you can see in the example here, okay, so you have a class rectangle, right? And here length and breadth are being initialized. Okay. And here we have one more constructor in which there are two parameters. Okay. Right. Here I have get, it doesn't take any parameter. This get is taking two parameters. So basically the overloading can be done with a normal method. It can be done with a constructor also. And please mind that destructor cannot be overloaded. Destructor cannot be overloaded. Okay, right. Okay. So whenever you give a call, it sees the matching number of parameters and type of the parameters. Based on that, the corresponding method with the specific number of parameters gets called. Okay, right. So it is called method overloading. Okay, that is also one of feature in object-oriented programming. Of course, in C language, if you have used multiple functions with same names with different number of parameters, it gives a compiler error. Okay, right. Okay, and generally it is assumed this that all the methods, okay, it is assumed that all the methods which use the same name perform some similar activity. Okay, right, similar functionality. Okay, so let us see if we have an example. If not, we can write one. Okay. Mm, fine. Looks like it's not there. Okay. So let us write one example. Okay. Right. Fine. So let us take the same program and let us change it. So we'll take the same rectangle class which we have seen in the slides. Okay. So rectangle. Okay. Right. So here actually, if you see, we are including Conio.h. Actually, it's a C language header file. I mean standard, okay, library in C language. Okay, so basically here we have access to all the C language functionality. Okay, all right, all the C language library functions. Okay, so rectangle. So rectangle. Okay, so let us write here as rectangle default constructor. That means a constructor which does not take any parameters is called default constructor. Okay. Okay. Let us assume this constructor is overloaded. Okay. Right. Okay. And by the way, there are two different types of comments in C++. One is this comment, which is single line comment. Okay. And the other is multi-line comment. Okay. So a single line comment starts like this. It can start from anywhere in the line like this. Okay. And it ends at the end of the line. Okay. Right. Which doesn't need any special, okay, uh, specification. Okay. At the end. Right. So in case of multi-line constructor, it is same as the C language. Sorry, multi-line comment. Okay. So this is a multi-line comment. Okay. So it starts with this and ends with this. Okay. So and it can span across multiple lines like this. Okay. Right. So as known, comment serves as the documentation. Okay. So just see that you add appropriate comments. Okay. So as known, we should not write the comments like what it is doing. That is anyway understood through the syntax. So basically you need to mention why you are doing, if there is any complex algorithm or anything which you are doing. Okay. Right. So thereby it improves the readability of the code. Right. Fine. So let me remove this. Okay. Okay. So let us have one more constructor. There is no rule that you need to perform constructor overloading, method overloading both at a time. Okay. It's right. So fine. So int, okay, say width, okay, int height, right. And or let me use the name w h, okay, right. So to avoid name collision, let us assume here I have int width and height. In the real world, of course, using float or double makes more sense. Right. So here what I want to do is I want to initialize width to something 10. Okay. All right. And height equal to uh, maybe 12. Okay. Right. So in this case, so let me mention as overloaded constructor. Okay. Right. Width equal to w, height equal to h. Okay. Fine. So let us have only one method which uh, which displays the area. Okay. So void. So this time let us not display there itself. Let us try to return the value, and let's get that return value from main method, and let us display in the main method. Okay. Right. So I'll return int. So get area. Okay. Fine. So in the get area, of course, I have access to width and height. Okay. So let me calculate the area here. So int area I declared, and area equal to width into height. Okay. Right. So return area. Okay. Fine. Now, yeah, we are using rectangle. So rectangle here. Okay. Right. So destructor, of course, there is no real use of destructor here. Okay. So anyhow, I just have it. I mean, we're just printing message there. Okay. Right. So let us create rectangle, okay, and as known, C is a case sensitive language, okay, so I'll just name it as rec, okay, right, fine. So here, whenever you do not specify parentheses and the parameters, the default constructor gets invoked, okay, right. So rec dot, okay, so rec dot, uh, I'll say get area, okay, so this method actually returns an int, okay, area equal to rec dot get area, okay. Now let us display it here, okay, right. Cout area of rectangle is, okay, area, fine, okay, fine. So now let us execute it. Okay, so as you can see here, the default constructor got invoked, okay, and the area of the rectangle is 120, okay, right. So let me see if I can increase the font of the output console, right. Let me go to preferences, general, so fonts. So we want to increase the font of this a bit. Not sure where is, okay, right, fine. So this is constructor overloading. Of course, we also have one more example. Okay, so here the constructor is overloaded, as you can see. Okay, so if you want to invoke the overloaded version, then you can specify the uh, parameters like this. Okay, and similarly, there is function overloading. So as you can see here, there. Okay, right. And one more point, what I want to mention is, okay, you can have multiple, okay, multiple methods, okay, with the same name and different parameters, which is method overloading, we already know, okay, but you cannot overload method methods only based on return types, okay. That means, say here I have a void int, oh, sorry, void area int as the parameter, okay, right. So I cannot have float, okay, this is syntactically invalid, okay, right, fine. Okay, let us take a look at this method, because there are some new concepts which we can learn from this sample code, okay. So as you can see here, there is a class, okay. Here we are naming the classes randomly, okay, but in your real project you may need to use appropriate names, okay, to improve code readability. So here we do not have constructor, we have three methods, and we don't have any data members, okay. Fine, excellent. See, as you can see here, I'm just providing the declarations of the methods, okay, and not the definitions. The definitions I'm providing outside the class. Okay. So whenever I'm providing the definition outside the class and I want to specify that here I'm providing the definition of so and so class, I need to use the name of the class and scope resolution operator. Okay. And the body of the method as usual. Okay. Fine. Right. Fine. There is a very small difference between, we can't say very small difference. There is a difference between defining a method inside the class and outside the class. Of course, obviously we know there is syntactic difference. There is some other difference, which we will see in next few minutes. Okay. So, right. So here we are creating an object. Okay. You're saying 1, 2, 3, 4. So we are saying enter your choice. The choice is being taken, and here there is switch. Okay, switch case and all this functionality is exactly same like C language. Okay, right. So I'll not talk much about that. Right. So here we are just doing a switch case and we are invoking it, and accordingly the area gets calculated. Okay, fine, and right, and it gets displayed. Okay, so if it's case 4, if nothing is entered, we are exiting. Okay, from the program. Okay, so exit means it's exit from the program. 0 means it's a normal exit. If it is any non-zero value exit, that means it's a error exit. That means in case something unexpected happened, like exception or something happened, so in that case maybe you can give 1 or -1 or whichever. Okay, right. Okay. Okay. Fine. Let us return 0 and put it as int. Okay. Fine. So let us execute it. I'll be sharing all these code examples. Okay. So it is here. So let me try to this function overloading, right? So let me copy it and let me paste it. Okay. Fine. So let us execute this. 1 second before execute. We have to paste it here. Function overloading last modified resources we want to override. Okay, is to all. Okay, right. So let us execute it. Okay, so it has executed, but there is a compiler error here. So it says no such file or directory. Okay, fine. So I think let us keep it as hash include IO stream. Okay, okay. And one more thing is, see, all the preprocessor statements are available in C++ as well, just like C. Okay. Okay, there is some error here. Okay, looks like it's an older version of the code. So there is no namespace. Using namespace std. Okay, then only cout, cin, and all this will be identified by the compiler. All right. Okay. So I made some changes to make it compilable. Okay, it's asking area of rectangle, enter with choice. Okay, so let me enter 1. Okay, so enter radius of the circle. So I'll just say 2.31. Okay, so it is displaying 12.56. Okay, and one more thing is here decimals are printed. The reason is okay. Uh, manipulator. Okay, I'll okay, fine. So here the decimals also printed. Okay, right. Actually, you can adjust that using some manipulators also. Okay, I'll give that example in the next sessions. Fine. Next. Okay, fine. So now let us take a look at different functions. Okay, right. Different methods. Okay, right. We have seen what is a method. We have seen what is. So we had seen regular method, normal one. Okay, and what is method overloading we have seen, and what is a static function we have seen. Virtual function we will see in inheritance. Okay, in polymorphism, runtime polymorphism. Okay, overloading a function is called compile time polymorphism. Okay, right. So now let us see what is an inline function. Okay, right. So it is a function with which we specify a inline keyboard. So whenever you use inline keyboard for the function, okay, what happens is there is no function call there. The compiler replaces the specific function call of inline function with the code of the function body. Okay, so what is the advantage of it means? It is just like a macro in C language, but it is better than macro, right? We know there are some disadvantages with macro, okay, but here it overcome some disadvantages of macro, okay. It's, we can say it's an intelligent macro, okay, right. But what is the advantage of inline function means? See, as we know, whenever a function is called, okay, is an entry is created on the stack, okay, and once that function is returned, that entry is removed from the stack. So like this, for every function call, there is some context switch which is happening internally, like creation of the frame in the stack, on the stack, removal of it, and creation of data, some local variables in that. Okay, but let us assume you do not. Okay, so basically there is a performance hit, very small performance hit there. Okay, so in case you want to avoid that, you can have it as inline function. But the best candidates for, so always the inline keyword given is not a mandatory. It's not mandatory that the compiler makes it inline. Okay, right? So, but it may or may not. Okay, let us assume you have a method with 30 lines and you mention it as inline. Okay, maybe the compiler does not make it inline internal. Okay, right. It depends upon the compiler implementation. Right. So the best candidates for inline is the methods in which there is one, 2 lines, 3 lines. These are the best candidates. Okay, right. And however, right, it is better than macro, but still it is not a real uh, okay, it's not a real function, and hence there are some limitations. Okay, it cannot be recursive. Okay, right. It cannot contain loops. Okay, so etc. It cannot have static variables. Okay, fine. So these are some limitations. Okay, if you have one or two lines, generally the getter setter methods, okay, those are the best candidates for inline. And one more thing what I want to tell is, see, as we have seen earlier, the methods can be defined inside the class or outside the class. Okay, right. If you define a method inside the class, okay, by default that is considered as inline. Compiler may consider that as inline. Okay, fine. But by any chance you want to define the method outside, okay, and you want to make it inline, then we need to specify inline keyword. Okay, right, fine. So we made this inline. Okay, right. Okay, let us just execute. Anyhow, we don't see any change in the outside function. I mean, we don't see any change in the output here. But okay, so what is the real advantage of inline means the actual function call doesn't happen. Okay, rather the compiler, when it's compiling the code, it replaces all the function calls with the actual body of the function. So the advantage is uh, there is no performance hit. Okay, however, there are limitations like recursion is not allowed and there are other limitations. Okay, so the compiler may very much ignore it. Okay, if you are violating like all these things using recursion, or okay, or some compilers may even show compiler errors. Right, when you use inline and recursion. Okay, I hope you are already aware of what is a recursion. Okay, so recursion means a method calling itself. Okay, right. We'll try to see an example. Okay, sometime. Right. Fine. So all the inline functions must be defined before the call because compiler need to go through the definition before the call. Okay. See here, if you see like here we have defined it. Okay. A get method, but this area method we have defined it outside. Okay. So this is a inline, but you want to define it outside and still want to make it inline, you need to use inline keyboard. Okay. Right. So that's about inline function. Okay, right. So C++ has provided with this many keywords, okay, and features. Okay, so we need to use all this effectively. For example, static is there, and access specifiers are there, and inline, okay, etc. Okay, right. So when we are writing the code or designing, so we need to make use of all these features. Okay, next. What is a friend function? Means a friend function has access to private and protected data of a class. Okay, it gets the access declaration in the class with keyword final. That means if there is a function which is not a member of a class, okay, and still that non-member function of the class wants to access the private or protected members inside that class, it is possible by using friend function. Okay, right. So it is not encouraged. Generally, it is not encouraged to use friend functions. The reason is there we are violating the object-oriented, um, okay, object-oriented concept. The reason is even though there is a function which is not a member of a class, It is outside, but still it can access the private members. Okay, right, fine. So, right. So here, if we see this code, we have a circle class and we have data member R and we have get area, everything is fine. Okay. And here, okay, this is a friend function. This is not a, this is not a, I mean, this is not a member. I mean, this is not part of the class circle. We are just specifying as a friend. So, okay, it is not a member here actually. So, but still it can access, okay, the private member. If you see here, we have a object of the circle, okay, and using we are using the private member, like the private R is a private member because we didn't give any access specifier. Okay, so if you don't give an access specifier, we know that it's a private. Okay, so we are able to access. So just because of this line, if this friend declaration is removed, then it will give compiler. Okay, fine. And as usual, this can be invoked directly. Okay, uh, since it is not the member of this class. Okay, so let us see an example for friend function. Looks like we do not have example here. So let us write it. Let us write an example. Okay, right. Function overloading. Okay, so let us change this code and try to use use a friend function. Okay, right. Let me change the functionality. Okay, so let us have int r. Okay, so I have data member r and I have, okay, let us see the example. Okay, I have r and we are getting the value of r. Okay, fine. Let us do one thing. Let us get the value of r through the constructor. Okay, right. So we will use this um, int. Okay, radius. Okay, so here let us initialize. Okay, r equal to radius. That means um, the value on radius is assigned to r. Right now, okay, let us make this as a friend function. Okay, and here say I want to take the object of as the parameter obj, and it's not part of the function, so I'm trying to, okay, change it accordingly. So function, uh, I use, maybe I can use obj itself. Okay, and here I just say obj dot r, okay, and one more obj dot r, okay. So let us remove all this code not required. So now let us create the object of, let us create the object of fn. So I'll say o f, okay. I'm trying to use some dummy names, but in real project, be cautious, okay. Fine, use the appropriate names, okay. So I'll say 4, okay, and uh, say I want to invoke area, okay. So I'm invoking area and I'm passing fn object. Sorry, I'm putting of, okay, right. So you may have some questions. Can we pass an object as a parameter? Until now we were passing int, float, whatever as parameters, but this is the first time we are sending object as parameter, okay. So I want to explain a bit more about that concept immediately after this friend function, okay, right. So the code looks okay, I suppose. So we have okay, fm, okay, looks fine. Let us try to build and execute. And let me try to rename it. Okay, so I'll rename this to uh, friend. Okay, function. Right. Okay, multiple definition. Okay, so there are old object files I think which are colliding with this. So let me delete them. Okay. Yeah. So we are able to very much compile and build it. Okay, right, fine. Okay, so this is about friend function. So to summarize, a friend function is a non-member function of a class. It's not a member function, but still it can access the private and protected members of the class. Okay, right, fine. So okay, so let us discuss uh, something about the objects which we were talking about. Okay, right. Okay, so in C++, we know that C++ is an object-oriented language. Okay, see one of the aim of object-oriented languages are it wants to use non-primitive data types exactly like primitive types. Okay, almost. Which are non-primitive types? We know class. Those are user-defined data types. That is non-primitive types. Class, and there are some more. Okay, right. Structure union. Okay, of course structure union are there in C language also, right? So can we send an int as a parameter to a method? Yes. Similarly, we can send an object of a class as a parameter to a class. Okay. So a parameter, okay, an object can be sent as a parameter to a method. It can be returned from a method, and even one object can be a data member of another class. Okay. An object can be a data member of another class. Okay. Right. So all these are very much valid. So I think just now we had seen one example for passing an object as a parameter to a function. Similarly, even you can return it. So when you are returning, then you have to specify the data type of the return here. Data type is nothing but the name of the class whose object you want to return. Okay, right. Fine. Now let us discuss what is operator overloading. We know that constructor can be overloaded, a function can be overloaded. Similarly, we can overload a an operator. Okay. So what is operator overloading means? So we just try to give the new meaning for an operator. For example, addition is there. Okay. So we know that using plus symbol, we can add to int, float, double, whatever. Okay. But even you can add two objects. Okay. So what does that mean? Means we give the meaning of it. Okay. For example, we have two rectangles. I have two rectangle objects. Okay. And I want to add them. And the business meaning for me is I want to add the width of one rectangle with the width of another, height of one rectangle with the height of another. Okay. So I have two objects, and when I use plus with both objects, I want the resultant object to get returned. Okay. And the meaning you can give as a developer what you want. Okay. All right. Fine. So let us see an example for that. Okay. All right. Okay. So here, okay, let us make some changes to the code. I think it's a, I did it few, okay, few days back. Okay. So I think it's, okay. So let me also using, let me also use the namespace. Okay. Because we will need it for C out and C in. Okay. Right. Okay, so basically it is a complex operation. Okay, so with the okay, we know a complex number, right? A imaginary number. It will have the actual value, and it will have the actual, and it will have the imaginary value. Okay, so basically what we are doing is we are trying to add, okay, two complex objects. Okay, all right. You may have a doubt like why we are passing only one, why not two? I'll talk about that in, okay, bit later. Okay, right, fine. So this is the example. Okay, okay. So as you can see here, we have a complex class, and here this is to get the value, and maybe you can also prefer constructor rather than a method here. Okay, right, because it will initialize the, okay, uh, fine, data members. So here what is happening is here we are adding two complex objects. See, we have one complex object. The other complex object is the one which is invoking it. Got it? So when you are using directly A and B, that is the object with which the plus operator is being invoked. Okay, right. And the right side one is not here. Okay, and we are just adding and we are creating one more complex object and we are returning it. Okay, since we are returning an object, we are specifying as name of the class which we are testing. Okay, right, fine. So this is operator minus. Okay, fine. So here we have two objects. Okay, here get value method is being invoked to take the input from keyboard. Here, if you see closely, we are invoking uh, obj2. Okay, if you see the syntax, here we are using operator keyword. Operator is a keyword. Okay, so when you use operator plus operator minus, so basically the operator keyword need to be uh, suffixed with the symbol. Okay, okay, which operator. So actually, this one also can be invoked as like this dot operator. Okay, plus this is also meaningful, but okay, to make it more readable. Okay, so we use it like this. Okay, right. So let us execute it. Some more compilation errors. So let us correct it. Okay, so let us enter the values of I'll enter as 1, 2, then I'll enter as 3, 4. So as you can see here, 1 plus 2i is one complex object, 3 plus 4i is one object. So when you add it, we are getting 1 plus 3, we are getting 4 plus 6i. Okay, right. So it's okay, right. So that is operator, sorry, yeah, operator overloading. Okay, fine. So as we're telling, object-oriented language wants even the user-defined types to be used as primitive types. Okay, right. So an operator can, sorry, an object can be used as a parameter to a method. It can be returned from a method. Even you can overload an operator, okay, and take object parameters. Okay, fine. So that is about operator overloading. Okay, and here we have overloaded an operator which are taking two parameters. Okay, right. Now let us take a look at operator overloading which takes only one parameter. So if you take a look at this example, this ABC, okay, we are getting the value of A and B. So here we are trying to increment plus plus. So whenever you are trying to use plus plus, so I want to change both the real and imaginary values. Okay, uh, I want to increment both of them. Okay, right. So okay, so here we don't need any parameter. The reason being, anyway, you are giving one object with which you are invoking plus plus, so that itself, okay, um, has one object. Okay, right, and hence there is no necessity to pass one more parameter. So okay, right. So why I am changing is it was a older version code, but the latest C++ compiler do not accept that. Okay, and cout is placed within std library. So without specifying it here, it doesn't allow us to compile. Okay, right. Okay, so let us, there is a build error. So just let us rebuild it. So it is asking for numbers 2, I'll give 2 and 3. So here it has incremented. After that it is 3 plus 4i, and after that again we are decrementing it. So as you can, I mean, as you observe here, okay, so here we are defining the methods. Okay, so within the class, and here we are getting the values. After that we are incrementing it. Okay, so whenever this is done, okay, a call is made to this one. Okay, so you can print a message here if you want to see the flow of the program, or you can debug. Okay, so that is about query operator. Okay, and I'm also providing some examples for if else and all, so you can just use it for reference. Okay, all right. Now let us discuss pointers. Okay, as known, just like there are pointers in C language, we have pointers here as well in C++. Okay, so the concept is entirely same. Okay, right. Um, okay, so let us discuss a bit about that, and after that we can see the examples. Okay, right. So just try to put some questions. I just try to put some questions here just to recap the pointer which you had undergone through the C language. Okay, right. So here AA is a pointer to an integer. That means AA actually stores an address of a variable which is integer. Okay, here this is pointer to a pointer. Okay, right. Fine. Why should we not return a pointer to a local variable? Okay, so some questions you can just analyze it. Okay, all right. Now, okay, so memory allocation. See, whenever we talk about memory, okay, there are an execution program. When a program is under execution in the main memory, there are four memory segments. Okay, one is code segment, the other is tag segment, the other is heap segment, the other is okay, a data segment, okay, right. So as shown in this diagram, when a program is under execution, there are four different segments. One is code segment, data, stack segment, and heap segment. Code segment stores all the compiled source code, okay, so that CPU can pick each instruction and execute. Data segment is basically stores all the static variables. So until now we were discussing few minutes back about static variables, okay, static data members, okay, or static variables within a method, okay. All those static members are stored in here, okay, right. That's why we were telling only one memory location is allocated and it is there throughout the program, okay, right. So the size of the static and global, this segment doesn't increase during execution. The size of code segment also do not increase, generally do not increase during execution. Here an entry is made to a stack whenever you make a method call. And if that method call is again calling another method, again another method, so it keeps on uh, creating an entry onto the stack, one after another. So what will be the entry in that stack means all the local variables like int, float, anything you store within the anything you declare within the body of the function or method, okay, right, is being stored here. And once that function is returned, functional method is returned, all the memory allocated for the local variables is being, okay, no more available, okay, once it is written from the function. Next, now heap segment. See here it is dynamic memory. That means, see, if it is a if it is a stack segment, the memory gets allocated when the method gets called and it gets deallocated when the method is returned. So we do not have control. Compiler does it for us. Okay, right. But in case of heap segment, okay, whichever memory you want, you can allocate wherever you want. Maybe you want to allocate in between the execution of a method, in between, and you don't want to deallocate it in that method. You want to deallocate in some other method. Okay, right. So, and similarly you can allocate and deallocate any number of times, okay, and that is heap segment. So basically the bottom line is we have to use new and delete keyboard to allocate memory from this heap segment, okay. It is also considered as dynamic memory, okay, right, right. So let us see some basic information about it. So how do you allocate a memory? Means, say I have a car, I want to allocate memory for that. So you can allocate like this. Okay. So this car is allocated from the uh, heap segment. That specific memory address is being stored in this. Okay. Here there is an array, but that array is allocated in the heap segment. That specific base address of that array is being stored in this. Okay, right. So that applies for this as well. Okay, right. So you can take a read at like each one of these. Okay, all right, offline. Right. Now, how do we delete it? So as we were discussing, once you allocate the dynamic memory, it is we who need to deallocate it. When, where, it depends on the requirement. It can be within the same method or maybe some other method, okay? But in case that memory is not deallocated, okay, during program execution forever, then it causes a memory leak, okay? So if you see these four segments, this is the segment in which memory leak can occur, okay? Right, fine. So how to delete means very simple. delete, you have to use the whichever the pointer. Okay, if the pointer is actually pointing to an array, it's uh, okay, you have to use square brackets. If you do not use square brackets, then if the compiler doesn't alert you, and there is a chance of huge memory leak. Okay, right, right. See, new and delete may not be in the same routine. Routine means method. Okay, right, fine. So you can just take a read at this large area from memory controlled by the runtime system that are used to grant dynamic memory. Okay, right, fine. So why we want to use dynamic memory allocation means you have full control. You can allocate any number of times. You can deallocate when you don't want, even before shutting down the program. So you can allocate it, deallocate it, allocate, deallocate. Okay, right. Okay. So let us see small examples for uh, okay, all right, pointers. So here is a simple example. Actually, we have three numbers here. We are taking it okay from the keyboard, and after that we are invoking this method. So to the method we are passing this one with ampersand. That means we are sending the parameters. Okay, sorry, we are sending the pointers to the three values. So what I'm trying to do is, um, so I get the address in value one, I have address, value two address, result I have address. So star of this one means I'll get the actual value which is inside that point, that address. Here also I'll get the address. Okay, here I'm trying to add both of them. Okay, and put it inside this address to which result is pointed. Okay, right, fine. So let us just execute it, and finally we are trying to print the result. Okay, right. So it's not that you can use pointer only in the parameter. Even you can also use it locally within a method. Okay, uh, right, or even as a data member of a class. Okay. God. Again, we have to change. No, it's fine. So looks like there are some errors first defined here. Multiple definition. Okay, I think that's because of. So I'll enter 43. I'll enter 65. Excuse me. Okay. So basically here both of them are, I mean, we're adding two parameters or through the pointers, and finally we are picking the result. Okay. Right. Fine.